Welcome to Understand the Math. In the video description, you'll find a link to guided notes that can be downloaded and filled in as you follow along with the video. In this video, I'm going to provide an introduction to the unit circle. I'll review the general equation of a circle, derive the equation for the unit circle, identify quadrants and quadrant points on the unit circle, and then complete some example problems on finding an algebraic point on the unit circle. Let's begin by reviewing the general equation of a circle. The center of the circle in our picture is equal to h, k. The radius of the circle we have notated as r, and any point on the circle is going to be equal to x, y. If we form a right triangle between the center of the circle and a point on the circle, we see that the length of the bottom left of the triangle is equal to x minus h. This is the difference between the x values. The length of the side leg of the triangle is equal to y minus k, and that is the difference between the y values. The Pythagorean theorem tells us that a side squared plus another side squared is equal to the length of the hypotenuse squared. If we compare this triangle to the triangle we have above, we see that A is equal to x minus h. That's the bottom leg of the triangle. We see that B is equal to y minus k, the side leg of the triangle, and C is equal to our radius r. If we plug these into our Pythagorean theorem equation, we end up with x minus h quantity squared plus y minus k quantity squared is equal to our radius squared. And that's the equation of any circle. The unit circle is a fundamental concept that helps us understand relationships between angles, coordinates, and trigonometric functions. Let's begin by looking at a circle of radius r whose center is located at hk. We found on the previous page that the equation for this circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. Let's now look at a circle of radius 1 whose center is located at the origin. So what this means is h, k is now 0, 0, and our radius is now 1. So this equation of a general circle now becomes x squared, because h is 0, plus y squared, because k is 0, is equal to 1. This, let's put a couple of stars here, this is the equation of our unit circle. I would definitely suggest that you memorize that. We're now going to identify the quadrants on the unit circle, as well as the quadrant points and signs of points on the unit circle. We'll begin by identifying the quadrants. In the upper right-hand portion of the circle, that is called quadrant 1. Quadrant 2 is in the upper left part of the circle. Quadrant 3 is the lower left part of the circle, and quadrant 4 is the lower right portion of the circle. it is typically done that the quadrants are written in Roman numerals. Let's now identify the quadrant points. Our first one is located at the point 1, 0, and this is where we would have 0 degrees or 0. Our next point is at the top of the circle, and this is 90 degrees or pi over 2. Our next quadrant point is located at minus 1, 0, and this is equal to 180 degrees or pi. And then our last quadrant point is located at 0, minus 1, and this is 270 degrees or 3 pi over 2. Let's now identify which points are positive and negative on the unit circle. In our first quadrant, every point is positive. The x value is positive and the y value is positive. In our second quadrant, our x values are negative and our y values are positive. In our third quadrant, both the x and the y values are negative. And then in our fourth quadrant, our x is positive, but our y is negative. It would be very helpful if you went ahead and memorized this. I think memorizing parts of the unit circle at a time is easier than just trying to memorize the entire thing at once. We're often asked to find the value of a point on the unit circle. If we look at our picture here, the point that I'm talking about is this point that I just wrote in purple. We're going to call this point xy. And we need to remember that this point is governed by the equation for the unit circle. X squared plus y squared is equal to 1. So every point on the unit circle can be described by this equation. To find a point on the unit circle, we need to start, and I'm writing this in red because this is really important. We have to start with the equation x squared plus y squared is equal to 1. Let's now look at some example problems. In our first example, we're asked to find all points. So let's go ahead and let's underline that. All points on the unit circle if y is equal to 1/2, and then indicate what quadrant these points are located. So we begin by noticing that every point on the unit circle can be described by x squared plus y squared is equal to 1. That's our starting point. The point that we're trying to find is going to be xy, which is equal to x comma 1/2. So the y we've already told is 1/2. So what we're doing is we're going to take this equation and we're going to solve for x to find the x value. So we're going to plug in y is equal to 1/2. And that becomes squared is equal to 1. So we have x squared plus 1/4 is equal to 1. So x squared is equal to 3/4, subtracting 1/4 from both sides of the equation. Now we're going to take the square root. Now, when we take the square root, we have to be really careful because we want to pick up both the positive square root and the negative square root. So x is plus or minus square root of 3/4, which is plus or minus the square root of 3 over 2. So our first point will be square root of 3 over 2 comma 1/2. And then our second point will be minus square root of 3 over 2, comma 1/2. Lastly, we're asked to indicate what quadrant these are located in. So let's just draw a quick picture of a circle. And let's remind ourselves, in this first quadrant, our points are positive. In the second quadrant, they're negative, positive. Third quadrant, negative, negative. And then in the fourth quadrant, positive, negative. And then we can put in quadrants. So this is 1, 2. Probably should have drawn my circle a little bit bigger, but it fits. Okay, so our first point, both the coordinates are positive. So this point is located in quadrant 1. And our second point, our first x value is negative, the y value is positive. So this is located in quadrant 2. In our second example, we need to find all points on the unit circle if x is minus 5 over 13, and then we're going to indicate what quadrant these points are located. Just like we did before, we're going to begin with the equation for the unit circle. X squared plus y squared is equal to 1. We're going to plug in x is equal to minus 5 over 13. And then we have plus y squared is equal to 1. Minus 5 over 13 squared is going to give us a 25 over 169. Plus y squared is 1. We now need to solve for y squared, so we'll take the 25 over 169 to the right. So this is, we can write the 1 as 169 over 169 minus 25 over 169, and we end up with 144 over 169. Now we take the square root, so y is either plus or minus the square root of 144 over 169. So y is plus or minus 12 over 13. Our x value is minus 5 over 13, so minus 5 over 13, comma, 12 over 13, and minus 5 over 13 again, and this time our y value is negative, so minus 12 over 13. And then let's include the quadrants. So this first one, x is negative, y is positive, so that's our second quadrant. And then the second one, they're both negative, and that happens in our third quadrant. Our last example is different from our first two. In this example, we need to find all values of x, let's underline that, so that the point x comma 2x lies on the unit circle. This problem is more algebraic than the other two, and I think it's going to help if we realize that our point x comma 2x is our point xy. And our xy lies on the unit circle, so our xy can be described by this equation, x squared plus y squared is equal to 1. Notice that's been the starting point in all three of our problems. Let's plug in now. The x stays as itself, but now for y, we're going to plug in a 2x. Square that. That's equal to 1. So let's do some simplification. So this is x squared plus 4x squared is equal to 1. So 5x squared is 1. Let's divide both sides of the equation by 5 so we can get x squared by itself. And then we'll take the square root. We have to remember the plus or minus. So plus or minus square root 1 over 5. So it says to find all values of x. So we actually did that. So let's just go ahead and let's box this just so it's clear that that's what we found. And then we can also say, okay, so that means these points are the square root 1 over 5, 2 times square root of 1 over 5, and minus square root of 1 over 5, and minus 2 square root of 1 over 5. It would probably be a lot nicer if we would just write this as 1 over root 5, 2 over root 5, and minus 1 over root 5, minus 2 over root 5.
If this